All right, welcome back for another part of our notes. So now we are moving on to 1.4 piecewise functions. So piecewise functions are when you have pieces of a graph all put together, and the way that we know the pieces of those graphs are because the domain is listed for the formula. So like the domain restricts it, says no, only from here to here is it this graph. And of course mathematicians like to write that in their own language. If you've had me before, you've heard me say mathematicians are lazy and they've created their own language. So that's kind of the idea there. So piecewise functions are functions defined by different formulas for different intervals of the independent variable. Standard notation is given in this format. So you could have as many formulas as you want. You can have, to be a piecewise function, you can have as few as 2. And there's really no limit to how much you could have otherwise. So you could have like up to 3, I guess. You could have up to hundreds, but in this particular class, you really won't see more than 3. All right. So the absolute value function is a piecewise function. So it's one of the more popular piecewise functions. If you recall, the parent graph of a piecewise or absolute value function, is this V shape, right? Well, if you notice, that is 2 linear functions or 2 lines, one with a negative slope, one with a positive slope. So with a slope of 1 to just be the parent graph. Now, we can change that. There are ways to change that slope, but for this particular one, it's just x and negative x. And honestly, usually we do left to right. So we're going to put negative x first and then x. So what am I talking about? Remember, mx plus b. M is the slope, and for this particular half, it's negative 1 with a y-intercept of 0. So that's how I got negative x. This one is the same line but positive, so it's positive 1x plus 0. And the change happens at 0. So we define it by saying when x is less than 0 here, and x is greater than 0 here. Now, here's the next part. It does have, one of those have to be equal to because it is a closed circle. It really doesn't matter which one because both of them work, but it is just standard to put one and not both. All right, so that's just an intro to piecewise. Try some matching on the next slide. Think about how many functions are there. So like if there are 3 formulas, 1, 2, 3, that means that there must be 3 parts of the graph. If you know one of the parts has an x squared, it has to be a parabola. Just to kind of get your feet wet with piecewise and see by process of elimination, can you match an equation with its graph? And we'll go into more detail.